Okay, section 5.6 is called the squares of binomials. So we're going to take a binomial, which was that a plus b, and we're going to square it. And once again, and it's not the same thing as a squared plus b squared. You have to actually write out the binomial twice, and then either FOIL or use the box method. And depending on whether you're taking a plus b or a minus b, it's going to change it just a little bit. We're going to use, it's kind of like a formula, almost. Except instead of a formula, they call it a factoring pattern. The left-hand side, these are called squares of binomials. Whenever you multiply them out, and what we're going to be factoring, what we're looking for, is called a perfect square trinomial. So that's the whole idea today, is to look for perfect square trinomial. But first, I want to be able to take a square of a binomial, and instead of writing it out twice and foiling it, or using the box method, I want to be able to use this factoring pattern and skip a few steps and make life easier. So for this first section, we're going to look at 2 examples. We're going to take the square of a binomial and write it as a trinomial using that factoring pattern. So I first have t minus 4 quantity squared. Now for any of these where you're asked to write the square as a trinomial, you could write it out twice, use the FOIL method or use the box method, but if you're like me, this is going to be a little bit easier. This is like the second example where I took a minus b quantity squared. It's like that one right up there. This tells me that whatever my first term is, I'm going to square it. And then to find my middle term, I'm going to take 2 times my first term times my last term. And then I'm going to add the square of my second term. So for this example, if we follow that factoring pattern, I'm going to square my a, but in this case, my a is t. So my first term is going to be t squared. Since it's t minus 4, I'm going to subtract my middle term. And my middle term is equal to 2 times a, but we just clarified that a is t, times b, which is 4. Okay, well 2 times t times 4 gives me 8t. And my last term, your last term today is always going to be a positive number. If you, for some reason, end up with a negative number, we need to go back and look at it. It will always be a positive number. And I'm going to square my b, or square 4, and I get 16. So instead of foiling or using the box method, I can multiply squares of binomials really easily. Okay, let's do another one. 6b plus 2 quantity squared. Notice this time I'm adding 2 terms. The only difference here is that my middle term is going to be positive and not negative. My first term, I have to square that first term in my binomial. So I need to take 6b squared. What do you get when you square 6b? 36b squared. Okay, my middle term, I'm going to take plus 2 times a times b, or 2 times 6b times 2, which gives me 24b. And my last term, I'm going to square my last term in my binomial. So I get plus 4. So once again, instead of foiling using the box method, you can easily multiply squares of binomials just using that factoring pattern. That's what those first examples on your homework are going to be today. Okay, I have 6 of these. We are going to go the opposite direction, and I'm going to give you a trinomial. First, we're going to decide if it's a perfect square trinomial. And there's 2 things that we have to check. And we'll go through that in this first example. If it is a perfect square trinomial, I'm going to factor it. If it's not a perfect square trinomial, you don't have to do anything to it. You just have to say not a perfect square. So our first example, I have x squared minus 6x plus 9. We could factor this using factors of c that add to b. You would get the exact same thing. So if you don't recognize that it's a perfect square trinomial whenever I throw all these different factoring problems at you, it's not a huge deal, but this is going to save you a lot of work, especially whenever we start getting these larger numbers. So if this is a perfect square trinomial, I have to check for 2 things. But before we check for those 2 things, we're going to start over at the very beginning. And what is the first thing we always check for? Greatest common factor. X squared, 6x, and 9, any common factor? Okay, no greatest common factor. Next, you're going to count the terms. How many terms do I have? 3. If you see that you have 3 terms, the next thing we're going to look for is if we do have a perfect square trinomial. If we have a perfect square trinomial, the first thing we should notice is if I have a squared number in the front and a squared number in the back, just like whenever we're looking for difference of squares. Do I have something squared that gives me x squared? Do I have something squared that gives me 9? 3. Okay, so that's the first thing, but that's not good enough to say that this is a perfect square trinomial, because if we go back to the factoring pattern, notice that I have to have a square in the front and a square in the back, but my middle term also has to be equal to 2 times a times b. And the easy way to check that, my a is x, my b is 3. I just have to look, does 2 times a times b give me my middle term, disregarding the sign?
Yes.
2 times x times 3 does give me 6x. Once you verify that, this is a perfect square trinomial, so factoring it gets really easy. Since my middle term is negative, I'm going to take x minus 3, and I'm going to square the whole thing. So 2 things we have to check for after we go through the greatest common factor and count our terms. We have to check if we have a square in the front, square in the back, and then we need to check our middle term. So let's try x squared plus 12x plus 36. Every single time we're going to start at the very beginning, because if you do not get in the habit right now checking for greatest common factor, you are going to run into so much trouble down the road, I promise. And it takes an extra second. Do I have a greatest common factor? No. How many terms? 3. Do I have a square in the front, square in the back? I do. What squared gives me x squared? What squared gives me 36? That's not good enough to say that it's a perfect square trinomial. That middle term has to match. Does 2 times x times 6 give me 12x?
Yes.
It does. Once you verify that, you're going to take your a and your b, and will I add or subtract them? You're going to add them. My middle term is positive, so I'm going to take x plus 6 quantity squared. And once again, if you don't recognize that this is a perfect square trinomial, and instead you're looking for factors of 36 that add to 12, you would come up with 6 and 6, and you would get x plus 6, x plus 6. You get the exact same thing. This is just kind of a shortcut getting there. All right, let's try 9t squared minus 3t plus 1. What is the first thing I check for? Do I have a greatest common factor? No. How many terms? 3. Do I have a square in the front, square in the back?
Yes.
I do. What squared gives me 9t squared? 3t. What squared gives me 1? Check your middle term. Does 2 times 3t times 1 give me 3t? No. It does not. That's why you have to check your middle term, because this is not a perfect square trinomial. So for your homework today, all you have to write is not a perfect square trinomial, and you can shorten it to PST. You cannot put anything else. You have to put not a PST. Don't be a minimalist. You can write not a PST. This is only if that middle term doesn't work out, or if you recognize that there's no square in the front, square in the back. Okay, I want you guys to try this one. 4x squared minus 20x plus 25. First, decide if it is a perfect square, and if it is a perfect square, factor it. Okay, we're always going to start at the beginning. Do I have a greatest common factor? No. Okay, no greatest common factor. How many terms? How many terms? Do I have a square in the front, square in the back? I do. What squared gives me 4x squared? What squared gives me 25? Does 2 times 2x times 5 give me my middle term? It does. So what is your factored expression? 2x minus 5 quantity squared. Okay, let's look at one with two variables mixed in it. Just whenever you guys are feeling super confident and ready to go. Let's try 9z squared minus 12zw plus 4w squared. You do this the exact same way. We're always going to start with the greatest common factor. Do I have one? How many terms? Do I have a square in the front, square in the back? What squared gives me 9z squared? What squared gives me 4w squared? Does 2 times 3z times 2w give me 12zw? It does. It sure does. Okay, am I going to add or subtract my a and b? Subtract. So my answer is 3z minus 2w quantity squared. You will really appreciate the perfect square trinomials when we get to Wednesday. Believe me, you will definitely appreciate that extra step just checking, because what we're doing on Wednesday can be a little tricky, but I'm really excited. Last one. 64u squared plus 72uv plus 81v squared. I want you guys to work that one out on your own. We are always going to start with the greatest common factor. Between 64u squared, 72uv, and 81v squared, do I have a common factor? How many terms? Do I have a square in the front, square in the back? I do. What squared gives me 64u squared? What squared gives me 81v squared? Does 2 times 8u times 9v give me 72u? No. It does not. Well, look, 8 times 9 gives me 72, and then I take that times 2 again. There's no way it's going to be 72uv. So what does that mean? Not a or a perfect square trinomial.